Welcome to Lecture 14, Section 3.5. Alright, so we are now looking specifically at linear functions. Alright, so remember, functions are things that, for each input value, you have only one output. We also have that vertical line test. But now we're looking at a specific type of function, so linear. When you see the word linear, what do you think of? Well, there's this word right inside it, which is line. So we are looking at the functions that are specifically lines. Okay? The specific type of functions. Those are the ones we're going to focus on at the moment. So, note, linear has the word line in it. For example 1, we're going to be given a table of values for some function. So for part A, we're going to write out the ordered pairs in the groups A, B, and C. Alright, so here's our table. And we are told A values are going to be these two groups. B's are going to be these two groups. And C will be these two. So I'm going to go ahead and write out those ordered pairs. So for A, let's do red for A. A was the ordered pairs, -5, -45, and 0, 5. Let's see, B. Let's do B in blue. B is 0, -5, and 5, 35. And last but not least, C. So C is 5, 35, and 8, 59. Alright, so we've written out the ordered pair groups. For part B, we want to find the average rate of change between each group A, B, and C. Okay, so average rate of change, remember? We did the formula for that previously. So the formula for average rate of change is y2 minus y1, so the change in y's over the change in the x values. So let's go ahead and do A. So for A, I'm going to go ahead and label these as my sub 1 group. So remember, the sub 1 should be in one group, and then this will be my sub 2 groups. Oops. Alright, so A is going to equal, the average rate of change for A. Average rate of change, and I'll just do sub A, so we know it's for sub A. That's going to be, alright, so we're taking the y2 value, -5, and subtracting from it the y1 value, -45. And notice, I use parentheses. Okay, please use parentheses when you're working with the average rate of change, because notice, see how many negatives there are? Because of so many negatives, you want to use parentheses, because if not, sometimes information can be lost. Just a word of caution there. Alright, so then for the x value, so we have x2 is first, 0, minus the x1, -5. Okay, go ahead and calculate that out and check back in with me in a second. Alright, so on the top we have 40 over 5. And 40 divided by 5 is 8. So the average rate of change for A is 8. Alright, let's do the average rate of change for B. Go ahead and see if you can plug in the values. Actually, first off, let's go ahead and label these together. So I'll go ahead and just pick the first group, as the sub 1s, and I'll pick my second group as the sub 2s. Doesn't normally matter which one is first. Okay, so filling this out, the sub 2, so 35 minus -5. Once again, the parentheses help in case of those double negatives. And then, let's see, 5 minus 0. Okay, so calculating that out, that's going to be 40 divided by 5, which is going to be 8. So the average rate of change for B is 8. And let's check out the average rate of change for C. I'll go ahead and label these ones. x1, y1, getting a little squishy here, x2, y2. Okay, pause the video, try simplify this out to find the average rate of change for C. Okay, so let's see, x2 is going to be 59 minus 35. And then we have x2 is 8 minus 5. So what's that going to be? So 59 minus 35, 24. And then 8 minus 5 is 3. So 24 divided by 3 is 8. Oh, interesting. Notice all the average rate of change for these ended up being the same average rate of change. So, something that has the same average rate of change, regardless of what points you used from it, if the average rate of change is same, this is going to be a line. Because the average rate of change for a line is constant, regardless of which points you pick. So for example, if we are looking, let me go ahead and erase some stuff up here so we can get a better idea. So if we're looking at a line, if I pick this point, or this point, and I'm counting rise over run for a line, let's go ahead and draw in the axes here. Okay, so for a line, so average rate of change is how your line, or how the graph is changing from one point to the other. So if I was trying to go from this point, right here, to this point, I go up 2 over 2. Average rate of change was 2 over 2. And then, remember on the same line, if I wanted to get from this point to this point, I'm going up 2 over 2. Okay, so the rate of change to get from one point to the next was the same. And that's what happens with lines. Your rate of change, your average rate of change is going to be the same across the whole line, regardless of which points you pick. That's the neat thing about lines. Not all functions have that quality to them. Alright, so average rate of change is very closely related to slope, or in a sense, it is slope. So the slope. The concept of slope arises in many practical applications. So when designing and building roads, engineers and surveyors need to be concerned about the grade of the road. So how the road is tilted. The grade, usually expressed as a percent, is one way to describe the steepness of the finished surface of the road. Okay, so if you're driving anywhere, I think mainly the mainland, I don't know if I see it quite as much here in Hawaii, but on the mainland you'll often see a sign that talks about the grade of the road or the steepness of the road. Alright, so for example, a 5% in grade means that the road has a slope of rise over 1 of 0.5, so from the percent to a decimal, which equals 5 over 100. So if you're talking about feet, that would be for every 100 feet that you run, you rise 5 feet. So remember, for 5 over 100, these are the change in the y values over the change in the x values. So you you run 100 feet, and then you'd be rising 5 feet. So for every 100 feet you go, you're gaining 5 feet in elevation. That would be a way to describe this slope. So for part A, if a road has a 5% upward grade over a 1,000-foot run, how much higher will you be at the end of that run than at the beginning? Alright, so what do we know? Well, we know that the rise over the run is 5%, which, remember, in an equation, we can't use percent. So we're going to go ahead and change that to a decimal, which would be 0.05, which is also the same as 5 over 100. Okay, so we know that the rise over run is 5 over 100. Now, we're going to go ahead and use the other information we were given, which was the 1,000-foot run. So let's go ahead and set this up as a proportion. So we're trying to figure out how much higher we're going to be at the end of this run. So we know that our run is 1,000 feet, and we want to know the rise, how much higher we're going to be. So we're going to set this equal to something we do know, which is the 5 over 100. Okay. So we're trying to find the rise, so let's go ahead and cross multiply this proportion. So we're going to get 100 times the rise is going to equal 5 times 1,000. Let's go ahead and still solve, so let's divide both sides by 100 to get the rise by itself. We can cancel those zeros there. Continue our equation over here. And we get rise equals 5 times 10. So the rise is going to equal 50. So what does this mean? Well, at the end of the 1,000-foot run, we will be 50 feet higher. All right, so for part B, we're trying to find the grade of a road that rises 26 feet over a distance of 500 feet. So we're trying to find the grade, and the grade is rise over run. So do we know what the rise value is? Well, the rise is 26 feet. Do we know what the run is? Yeah, 500 feet. That's the distance, the length. So 500. So to find the grade, we're going to go ahead and try and make this into a percent. So we'll do the division. So that's 26 divided by 500, which is calculating. All right. 0.052, which as a percent is, remember, move the decimal over twice to make it into percent. Boop, boop. That is going to be 5.2%. So the road has, remember this is a word problem, so we need to write a sentence for our final answer. The road has a 5.2% grade. All right, okay. Let's go ahead and box our final answers here. And remember, with the periods at the end, I do search for the periods because these are supposed to be complete sentences. So there should be a capital letter and a period. All right, so let's look at the next page. All right, so slopes of lines. One of the main things we tend to look at with lines are the slope, which is also the way that the line is, and you could say, tilting. So for example, different types of lines. We have this line. It's going upwards. This line going downwards. So when I say going up or down, think about how you read a book. When we read a book, we start from the left and we move to the right on a page, right? So that's the same way you would read a line. You start on the left side of the line and you look towards the right. If when you start on the left and your line is going upwards, that has a positive or an increase in slope. If you start from the left, which you always do for lines, and you look to the right, and our line is going down, that is a decrease in our slope. Okay, so remember, always left to right. Just think about how we read books in America. All right, so for example 3, how to find slope when given certain information. Okay, so a way I like to think of this is if you're in Kailua, there are many different ways to get to town. Right? So, let's see. I don't know if I can really draw a good map of Oahu. It's a really bad map of Oahu. Okay, so let's say you're in Kailua and you want to get to town. And you got, the nice mountain range here. There are definitely more than one way to get to town. But you could go through one of the tunnels to get to town, right? Or you could go around near Hawaii Kai and get to town. That's longer. Or you could go, I don't know why you'd want to do this, but you could take the super scenic route and get to town. There are lots of different ways to get to town, right? So sometimes, if, let's say, the poly's closed, if some random rubble falls on it, that route is out. So you only have these two opposite routes to take. Or maybe they're fixing the road near Makapu'u, and you cannot take this route, which means you'd have that route and that route. So a lot of times, the route you can take depends on what's available, right? Same thing happens when finding the slope for a line. There are many routes to take, but it also depends on what is available to you as information. So here are different types of information that you might be given. Depending on that information, you can find a slope. So if we're given 2 points, here's the way to find a slope. So if you're given 2 points, x1, y1, and x2, y2, you can find the slope by this. M equals y2 minus y1 over x2 minus x1, which looks really familiar because this is what we've been using as the average rate of change, which is the slope. Okay? And please note, we use the lowercase m to indicate what the slope is, to think of m for mountain, the slope. And also please note, we use lowercase m. We do not use, what is that? We do not use a capital M for slope. Okay, if I see a capital M, that more than likely I will be deducting some points for that. Okay, that does not mean slope in math language. All right, next thing, if you have a graph, how would you find the slope from a graph? Well, a way to find slope from a graph, let's go ahead and draw a line on a graph here. Oops, back that up. First off, let me label this axis here. Let's do 1, 2, 3, 1, 2, 3. Boop, boop. Okay, so we have 2 points. Let's go ahead and draw in a line here. I'll label this 3, 3, 0, 0. Okay, real quick. The point in the middle, what is that called? That has a special name. This point in the middle is where everything starts from, so we call it the origin. Okay? It's a good way to remember the beginning of everything. Alright, so here's my slightly crooked line. To find the slope for my slightly crooked line, what you do is you count rise over run. Okay? Rise over run. So, let's say I wanted to get from this point here to that point over there. There are 2 ways you could go. Actually, there are more than 2 ways. But here. So we have 1, 2, 3. So I rise 3. I'm running out of room here. So my rise would be up 3, so that's going to be positive 3. And then I move to the right 3 more. 1, 2, 3. Over 3. That's one way to find my slope. You might ask, well, could I go the opposite direction? And the answer is yes, you can go the opposite direction. Oh, I just erased all of that. Did I want to do that? I'll just say yes, I did. Let me go ahead and redraw this in so we can show the other way. Alright, so let's say you wanted to choose to go the other direction. Does it work? Alright, so let's start from here and try to get to this point. Well, I'm going to be going back 1, 2, 3. Ooh, I made that a little off. Okay. Back 3. So when we're moving back, that's considered negative. So we're moving back 3, and then we're moving down 1, 2, 3. Down 3. So going down is also a negative. So the question here is negative 3 divided by negative 3 the same as 3 divided by 3? Because remember, I said either method should work to find the same slope. Well, yeah, they are the same, because 3 divided by 3 is 1. And negative 3 divided by negative 3 is also positive 1. So either method worked. Another method, if you felt like doing it, could be going down this direction and then counting back that direction. Or if you really wanted to do it, you could count this direction and then go up that direction. So there are actually 4 possible ways to count the slope, and they all will give you the same answer. Just remember that if you are going backwards, if you're going to the left when you're talking about run, it should be a negative number. And if you're going down when talking about run, it should also be a negative number. So back and down are negatives, forward and up are positives. So think about in life. You want to be moving forward and upwards in life. Those are positive things. In life, you do not want to be moving downwards and backwards. That's negative. All right, lastly, the other way to find slope is via an equation. All right, so let's say you're given the equation y, I want black. Y equals mx plus b. So we have a lot of variables in here. The main variables that you will see that are actually going to be numbers in an equation are your m and your b values. Now remember, what does m stand for in mathematics? M stands for your slope. So right here is my slope. So the main thing to notice for this, if your equation is in this very specific form, we have y equals a number times x plus another number, if it's in this very specific form, then you can just pull your slope straight out of it by whatever number is attached to the x. So for example, if I had the equation y equals 1/2 x plus 2, because this is in, and we call it the slope-intercept form, if your equation is in the slope-intercept form, I can just pull my slope right off of it by whatever is multiplied to the x. So ask yourself for a second, what number is being multiplied to the x? Well, it's that half. So my slope for this example would be 1/2. Alright, so those are the three ways to find your slope depending on what you are given. Either 2 points, a graph, or an equation. Alright, so example 4, we're going to spend time identifying the average rate of change, or the slope, for each of the following functions. So we're already told these are functions, so we don't have to spend time worrying about figuring that out. So let's see, how would I find the average rate of change for A? What information am I given? Well, I'm given a graph. Which means, what plan should I be using to find the slope? I should be using rise over run. Alright, so rise over run. Oops. So m is going to equal rise over run. I'm just going to go ahead and start from the -3 and move up to 2. Ooh, that graph's a little off. Okay, so we go up 2. So my rise is a positive 2. And then we move forward 1, 2, 3. So forward 3. So my rise, or my slope, is going to be 2/3. For B, what am I given for B? For B, I'm given 2 points. So I'm going to use this formula for 2 points. Okay, we have used this one before. So let's see. Let's label these ones as my sub 1s. And these are my sub 2. Go ahead and try to fill out the equation and check back in with me in a second. Sorry, so m is going to equal, well, my sub 2's first. It's going to be these guys. So -3 minus my sub 1s, which are those. Oops. -1. Sub 2, this 3. Minus the sub 1, -1. So that would be -3 minus 1, -4. -3 plus 1 says +4. -4 divided by 4 is going to be -1. And as always, please write your final answer with the m equals, okay? Do not just write 2/3, because this is the slope, and as I said, it's an important concept or an important piece of information for lines. Please include the m equals to clearly indicate to your reader what your answer is for. All right, 2 more to go. For C, what am I given? Well, I'm given a line, an equation. So the plan is to use the y equals mx plus b form. And once I get it in that form, I just take out the m. So quick question, is this equation in the proper form? Well, yeah, it is. We have the y equals an x value plus a 5. So because it's in the proper form, we'll just snag the number in front of the x, and that is our slope. So m equals 3/4. Once again, please notice I wrote m equals, not just 3/4. For D, let's see, what are we given? Well, this looks like an equation. So you might be tempted to go, okay, let's just take whatever's near the x. Boom, 3. We cannot do that. Why? it needs to be in this form. It is not in that form yet. Okay, that's a very important thing. It needs to be in the correct form. So we need to solve for y. Okay, let's go ahead and solve for y. Actually, you can pause the video, try solve for y, and check back in with me in a second. Alright, well, solving for y, let's go ahead and subtract 3x from both sides. Alright, so then we got to get y by itself, so let's go ahead and divide by 2. Got to divide everyone by 2. Okay, remember, divide all of those terms by 2 on that side. And then, let's see, so I have y equals negative 3 over 2x plus 17 over 2. Is this in the proper form? Well, let's see. We have y equal to the x value plus the number value. Yep, that's the correct form. So now I can pull off my I can pull my slope off of the x value, and there it is, negative 3 over 2. So m equals negative 3 over 2. Okay, so notice, that was definitely not our slope value. 3 is not our slope. Our slope is negative 3 over 2. Alright, that is it for this video. Please email me if you have any questions.